3.6 chain rule video. So your objectives are to be able to solve problems involving derivative calculations, second derivatives, and finding derivative values. So why we're studying this is when we have more complicated equations, we may need to use composite functions. Like if it's f circle g, then we put f of g of x. So as an example, how do we differentiate capital F of x equals sine of x squared minus 4? So here they're going to have u notation, and they're saying the function of u equals sine u, and then the u is the inside part, which is the x squared minus 4. And then we can differentiate them from previous sections and use the chain rule. The chain rule says the derivative is the product of the derivatives of f and g. So the derivative of the composite function is the derivative of f at g of x times the derivative of g. And again, on u notation, if f of u is differentiable at the point u, which is g of x, and if g of x is differentiable at x, then the composite function would also be differentiable. And remember, the derivative is noted with the apostrophe. And so f circle g prime would be the same as f prime of g times g prime. Now, in the person Leibniz notation, if y equal f of u and u is g of x, then dy dx is the same as dy du times du dx, where you evaluate it. Now, what I remember is in the book, it uses dy dx, and Math Excel uses y prime. It doesn't really matter. Those mean the same thing. So now we're going to talk about the outside-inside rule. So again, outside, inside. So the difficulty with Leibniz notation is that it doesn't state where the derivatives are supposed to be evaluated, and so you use function notation then. So if you have f of g of x, then you do f prime of g of x. So in other words, keep it the same thing, and then do the derivative of that. So in words, you differentiate the outside function and evaluate it at the inside. And you leave it alone, and then you multiply by the derivative of the inside. So there are your different ways to write your chain rule. I'm not going to read through them. You can. It is possible to do 2 or more chains. Those are just more complicated problems. And then you have chain rules with powers of the function. So if you have f prime of u, then you put your n in front. Okay, so if we have u to the n, then we bring the n to the front, keep u the same, and then lower it a power. So that's why we do the exponent rule minus 1. So it's n minus 1. So if this were f of x equal x cubed, then f prime would be 3x squared, because we take our number, put it in front, and lower this by 1. But in our case, what we're about to do is a little more complicated, because we say, what if you had sine of x cubed? Then you say the derivative of sine is cosine, keep x cubed the same, and then what was the derivative of x cubed? It's 3x squared. So then we put 3x squared cosine x cubed. Make sure you don't multiply whatever was in parentheses, your parameter argument, by that. You got to put that in front. And you'll see examples like you usually do. And here's just different ways to say the same thing. Now, when you are doing the absolute value of the absolute value function, then it turns into piecewise. Absolute value turns into piecewise. And so if it's bigger than 0, then it'd be 1, which means like that, because that's 1. And if it's less than 0, which means to the left, then it's -1. Left of 0, right of 0. Okay, so that's the piecewise. Now, when you are doing your derivatives of trig functions, you have to use radians, not degrees. And then here's just a little formula. you'll see the formula going into effect like when we do our problems, because right here it just looks like a little complicated. Okay, so let's get started with the problems. So on this first one, they're giving you f of u is what the y is, and g of x is what the u is. And they want you to do dy dx, which is the same as f prime of the g function times the g prime. Well, what they're telling you is you have 8u plus 1, but then u is 1/2 x to the 7th. So what you first do is you can either say dy dx or you could say f prime. You're going to say the derivative. First, I'm going to write down the problem. Y prime, which is dy dx, would be 8 times u prime, basically, because the derivative of constant 1 is just 0. And now we got to plug in I think first, we need 8u u prime. So 8 times 1/2 x to the 7th times the derivative of that, which would be 7/2 x to the 6th. Okay, so I shouldn't have second guessed myself because I was already right. I just wanted 8u prime. You don't need that extra u. And so that'd be 8 times 7 times 1/2 x to the 6th. And so that'd be 56 times 1/2 x to the 6th, which is 28x to the 6th. And that is what we want here. So pretty straightforward. Now, if you wanted it what we called, well, if you didn't want, or if you didn't use u, then you'd make it 8 times 1/2 x to the 7th plus 1. And so that'd be 4x to the 7th plus 1. So that's your function. And so f prime would be 4 times 7 is 28, x to the 6th. And again, the derivative of 1 is 0. And so again, that's what you should get. All right, for our next part, you do your derivative of cosine. And the derivative of cosine is negative sine. And then we want u prime after that. So this would be negative sine 4x plus 5 times the derivative of 4x plus 5 would be 4. And so that's negative 4 sine 4x plus 5. And that's what we have. So remember, when you're taking your derivative, it's just the coefficient if all you have is a linear term. Now this one looks a little more complicated. So I'm going to rewrite that as y is u to the 2/3 power. Remember, the root would be your denominator and the squared part is your numerator. So when we do that, then you'd say y prime would be 2/3 u to the 2/3 minus 1 means 2/3 minus 3/3, which is negative 1/3. And again, we need the derivative of u. Okay, so this would be 2/3. U is sine x. And we need that to the negative 1/3. And then multiply by the derivative of sine, which is cosine. So then we call that 2. We want the 3 in the denominator. We want this part in your denominator. Because it's a negative exponent, we want to bring it down. Sine x to the positive 1/3, and then I'm going to put cosine x. Now, the only difference between these is I used a fraction instead of a square root. So that'd be 2 cosine x, 3, do your cube root, and then sine x. And that matches. Okay, on the next one, we have negative 2 sine u, and so your derivative would be negative 2 cosine u, and then we got to do times u prime. You might want to do u prime separate if it helps you. That'd be just negative 4 minus, the derivative of cosine is negative sine. So this would be negative 4 plus sine x. Now, if you notice, I did just bring down this. Well, I probably should have went ahead and substituted. It's like u is the negative 4x minus 2 cosine x. And I kept the right side the same. So there's your negative 2 cosine of that times that. Now the only difference that I see is I dropped a 2 right there. I sure did. My 2. Okay. So there it got it. Negative 2 cosine the u expression, which is basically this, and then your derivative of that u, which is negative 4 plus 2 sine x. So that's your answer. On this one, you're doing the derivative of tangent. So remember that if y is tangent, then y prime would be secant squared. And so this one, the u is the 7x minus 6, and so we can say secant squared 7x minus 6. And don't forget the u prime. So the derivative that's inside part is 7. And so we get 7 secant squared 7x minus 6. As a reminder, if you need your derivatives of your trig functions, in your 3-5 notes, the derivative of sine was cosine. The derivative of cosine was negative sine. The derivative of tan is secant squared. The derivative of secant is secant tangent. The derivative of cotangent is negative cosecant squared. And the derivative of cosecant is negative cosecant cotangent. So you're going to want to jot these down or keep your notes. So that and this one and this one. So basically 3a, 4a, and this little 1, 2, 3, 4. Okay. So derivative of tangent was secant squared. On our next one, we have 3x plus 10. And so, like, using the u notation, this would be like u to the 6th. And so y prime would be 6u to the 5th u prime. And so then just say that's 6 times 3x plus 10 to the 5th power times the derivative of the inside is 3. So then you do 6 times 3 is 18. And then 3x plus 10 to the 5th. So that'd be what we were looking for if you did it like normal, which is this part. Now, they do want you to break it up into sections. So you say this part is the u, and so it's u to the 6th. And then the inside part is the g. So this is the outside, and this is the inside. Okay. On this one, basically the u is the inside. And then they want you to write it as u to that power, so u to the negative 4. And then they want you to actually do it. So if y is u to the negative 4 power, then y prime would be negative 4u to the negative 3 power with u prime after it. And so this would be negative 4. The u is the square root of x over 9 minus 5. We need that to the negative 3 power. And then we have to multiply by the derivative of u. So if u is 1/9 square root of x minus 5, see how I just made that 1/9? Then we could rewrite that to be 1/9 x to the half minus 5, because these are equivalent. And then when you're doing your derivative, 1/9 times 1/2 is 1/18 x, and lower by a power, so you get negative a half. And the negative a half means the square root of x goes on bottom. Okay, so I didn't really need it open that wide. Looks like that. So now negative 4 times 1/18 is negative 2/9. So you have your negative 2 and you have your 9. We also have your square root of x on bottom, because that's like that. And then we have this expression. Oh, and I just made a little mistake. You're supposed to lower by 1, so that's -5. So these need to change to 5s. There we go. Okay, so that's how you do that one. Okay, on this one, we're going to make it as u to the 6th. And so you want the one that says u to the 6th. And then this inside part is the g function. And then you actually do it. Okay, so if we have y is u to the 6th, then y prime would be 6u to the 5th u prime. So we say 6 times x squared over 8 plus x minus 3 over x times the derivative. Now the derivative part of u is the more complicated part. So over to the side I'm going to put g of x is 1/8 x squared plus x minus 3x to the -1. You see how I just rewrote that? I made x squared over 8 to be 1/8 x squared, and then plus x, then minus 3, and I wanted to bring this up from the exponent rule. And so that makes it easier to work with. So now I do 1/8 times 2 times x plus 1, because the derivative of x is 1. And then you do -3 times -1 is 3x to the -2. So now I say 1/8 times 2 is 1/4 x plus 1 plus 3 over x squared. And that's pretty much the same as this. It's just now they have it as x over 4. So all I'm going to change is 1/4 x to be x over 4. And that's how we make it match. Okay, now on this one, you just choose this to be u as cosine and y as u to the 4th. Remember that in your calculator, you'd have to do it like that. If you were graphing it, but these were not really graphing it. So if we have y is cosine 4th x, then y prime would be 4 cosine go down a power, so 3. And the derivative of cosine is negative sine. So this would be -4 cosine cubed x times sine x. Like that. That looks like a good stopping point for that video. Hope that helps. Have a good day.